Hello and welcome to this Micro Drainage Live webinar. My name is Daniel Swan and I'm the new Marketing Manager here at Micro Drainage, an XP Solutions company. Today's webinar is entitled Micro Drainage, WinDes 2013, What's New? And we'll be discussing the helpful new features that are now available to you in the latest version of WinDes. Today's presenters are James Berryman and Peter Coombs. James has been with Micro Drainage for over 5 years and holds a Bachelor of Geography Planning and a Masters of Sustainability Planning and Environmental Policy. Following James, Peter Coombs will present. Peter has been with Micro Drainage for 11 years. He is a Chartered Water and Environment Manager and has also worked in the construction industry in the drainage field since 1976. Welcome, James.
Good afternoon, everyone. So I'm going to be taking you through a brief introduction to the key new features from a design perspective in the software. The first part which we're going to start with is our update to the MD-CAD module. So many of you may already have that on your license. Others that have the DrawNet module currently on your license will now also have the option to run either DrawNet or MD-CAD, which is now known as DrawNet CAD. So what is DrawNet CAD? Basically, it's very similar to DrawNet in that it provides a graphical interface to WinDes, but instead of working within WinDes itself, you can work in the AutoCAD or Civil 3D environment. So you can see on your screen now, this is DrawNet CAD. Up on the top, you have all the different buttons, which you'll probably be reasonably familiar with from the WinDes interface. If you look down here, you can see what we're going to be working with today is sort of a basic standard drainage layout. Currently in here, we already have one network running down through there. That's our FAL network. If we go to the network manager just here, we can see the FAL main drainage network that's currently in there. What I'll do now is I will load in a MDX file. So the same file formats is what you'll be familiar with as working with WinDes. So I'll bring that in over the top of the drawing file in the background, and what you'll see is a storm system going. So it'll be a new network. Okay, on that first warning I get up, would I like to update the cover levels for the design with the tin levels inbuilt into the AutoCAD, or in this case Civil 3D model. So I'll go yes on that, and that will automatically update all my cover levels. You'll now see the network following the main road layout across the site. We've now got both networks also in this list for our network manager. So I'll make sure the storm water network is populated. One of the big advances with DrawNet CAD over MD-CAD is the ability to adjust the network details in much finer detail. So if I pop up the network details, they look identical to what you'd be familiar with if you're using System 1. What we've brought in is the ability to optimize your system and run the modified rational method or the rational method in the background. So you can see all our pipe levels, cover levels, and various other parameters, and all the optimized features in the top left-hand corner. What I show you is the basic premise of DrawNet CAD is the ability to specify pipes graphically. So instead of having to type everything into spreadsheets, you now have the option to draw them onto your design. So draw on a branch line just down here. As you draw it, it will automatically number the system, automatically pick up the cover levels, grab the manhole coordinates and the pipe length. So it takes away a lot of the sort of manual work when it comes to setting out your pipe system. So you can see there, quite simply, you can add in those 3 pipes and everything's updated. So we go back to the network details. We should see them appear in the list. So maximize the screen. We were working with these pipes here, so you can see that it's largely the pipes which have no invert levels. Because we have yet to specify those. Instead, we can use the Optimize engine. We can click yes on there. So go Optimize and click yes, and now the levels have updated. So instead of being down at 0, they're now up to more sensible levels. Should still achieve self-cleansing velocities, minimum cover, and adequate capacity for the pipe diameters to take the flow. Currently, you see we're not achieving the proportional velocity on these pipes. That's because we have no areas assigned to them right now. So if I go back to our design, We have a few different options within DrawNet CAD to specify areas. One of the key ones is the ability to set up different PIMP classifications, so different PIMP zones. So if I set up a couple in here, one of them being impermeable with a PIMP of 95, and then I set up a second one which will be permeable. And I will give a PIMP value of 40%. With these, I can then classify my design to include the different types of percentage runoff, and then I can specify the area. So if an area getting into a manhole includes both gardens and verges, as well as paved areas and roofs, I can specify that area as 1, and it will identify the different ratios of impermeable and permeable, or however many different PIMP classifications you may have for the different parts of your site. So I go yes on the form. Now I can specify my PIMP zones. So to start off, I'll do an impermeable area. So select impermeable, we can snap on the drawing. I draw around the house roofs at this location, and that will be 95% runoff or 95% impermeable for these for this roof area here. So you can see the lines, the dotted line which surrounds it. I then set up a second one, which is a permeable area. So I put in the gardens in the back. Roughly, and again now I have the second part of that sort of house plot with 40% percentage impermeable. I can now, with those two set up, define my areas. So if I was to define the area getting into this manhole, use as zoned, and then select the whole plot for this upper one. And there we go. So that's the first area coming into this location, and I can define a second one down here. So again, as zoned. And there's a second area coming in. So they will now use a combination of the two different percentage impermeables. If we go back to the network details, we can now see for pipes 3 the percentage in the area coming in, and the same for pipe 2.001. We also now see down in our proportional velocities that we're achieving self-cleansing velocities. Not on pipe 2, that's just because we don't actually have any area specified on there at the moment. And I'm not going to spend hours typing in more areas. So I'll show you some new other features. So other things you can do in DrawNet CAD, you can view your long sections. So very similar to what you'd be familiar with from the main WinDes suite. So we can set them out, for example. You can also plot those and do many of the other features which are available throughout the other package. So crosses and conflicts, insert manholes, move manholes, and everything else. One of the key things we've added in version 2013 of the software is a new module selector. Many of you will be familiar with the previous satellite diagram and how we used it in version 12 of the software to navigate between the different modules and which ones you had open or closed. In here we've tried to simplify it by basically you select the module which you wish to have turned on and it will highlight. If you don't want it on, it grades out. So currently we're working in DrawNet CAD, so we have System 1 for the modified rational method and optimize engine, APT to pick up the cover levels from the digital terrain model, and DrawNet for the graphical interface. What I'd like to do now is take my design which I created here in DrawNet CAD into the main WinDes suite. So I select the network module, and that will open up all the main modules available in the suite. So I should expect to get System 1, Simulation, Cost, APT, CASDEF, and FlowFlow. So these are the modules available on my license. You see down here, DrawNet, Simulation, Cost, APT, CASDEF, and FlowFlow. So with that open, and I'll open up the file we're working on. What I can do is I could turn off any of these modules if I wanted to, but Generally no real reason why you wouldn't want to run with them all at the same time. The benefit of running with them all at the same time is I could be designing my pipe system in System 1, then I could add on some ancillaries like a flow control or a storage structure, and then if I run an analysis and find I need to increase capacity and upsize some pipes, I don't have to save the file out and take it back to a separate XE for System 1. I can do it all within the same interface. So here's the same design as what we was playing around with earlier on. So you can see all the pipes laid out and the area where we added in some additional pipes. What I'll show you now is how to add on a few extra ancillaries and what we've added on to the ancillaries in 2013. So up here we've got all different types of flow controls. So for example, on this storage structure, if we wanted to limit the flow from the storage structure so we was able to maximize the amount of water held back and fill the storage structure to its capacity, we could have a orifice with a design head of say 1.5 and an outflow of 10 liters per second. The downside of using an orifice is you end up with a diameter less than 100 millimeters, so it may not be adoptable by some authorities. So instead we could switch it for the new ACO Q brake, so a new flow control which has gone in 2013. To specify the Q brake, it's very similar to the orifice. You just need a design head and the design flow. Once you have both of those in, it automatically calculates your head loss and flow, so your depth flow relationship. And you can see by using a vortex control instead of a standard orifice, we get a diameter of 109 millimeters, and so it should be adoptable now at that location. What I'll also show you is some of the new features we have in the source control module. So to launch source control, I can go to the window menu and select the module selector up here. So the same as what we saw before. We now see lots of the modules are highlighted because we're running them all concurrently. To launch source control, you just click on source control in that list and it will start the XE and it'll start it loading up in the background. What we'll look at sizing up is some basic house soakaways or some small storage structures just to go in the house gardens for some of the properties we're looking at on our design. So we'll go ahead and start a new job, specify the storage structure as a house soakaway, the outflow as an orifice, and we won't have any overflow, so we set that to none. Go OK on the global variables and it pops up the rainfall details. So we're designing it for a 30-year return period. We just click on the map and just grab Swindon for our rainfall of M560 and ratio of 20 and 0.4. We'll be running all the storms from a 15-minute to a 7-day storm, but we won't include any of the network details upstream because we're taking the water basically directly off the roof and into our storage structure. We go OK on that. The actual dwelling which we'll be sizing it up is we're running the scenario that it may be a block of flats or something like that. So we'll say it may have a roof area of 0.05 hectares, so about 500 meters squared roof. One thing you may notice on the time area diagram form is the addition of the rainwater harvesting features. It's something we'll come back to in a minute, so we just size up the structure first so I can show you some of the new outputs we have on the summary of results. So go OK, a time area diagram, and it pops up our house soakaway structure. So I put in a cover level, I give it an invert level, I make it 1.5 meters deep, I give it a pit width, so it's just going to be 1 meter by 1 meter, we're just going to have one of them. I cap the depth at 1 meter as well, so basically we have storage up to 1 meter, then above that we assume it'll be filled with whatever cover material is going back on top, apart from the manhole itself. OK on there, and it pops up the orifice outflow control. So we just size it up roughly just for the 1 meter head. We know we've got action on it, just make it 5 liters per second as our discharge rate. We set the invert level to be the same as the invert level of our storage structure. Once we have all of those in there, we can run the analysis, run all the storms, and it pops up the results. So you can see we've got a small amount of flooding on site. One of the key features we've added into 2013 is 2 additional columns in the source control. First being flooded volume. So we can see we have a flooded volume at this location of 3.4 meters cubed. We've also added in the discharge volume. So leaving out of the orifice on our house soakaway, we have 8 meters cubed. You can see for some of the longer storms, we see a greater discharge. The one that's highlighted in red is the critical storm. what we can look at doing to solve this flooding, if we go back to the Edit menu, we can bring back up the time area diagram, and I can demonstrate the new rainwater harvesting tool. Select the button, and it pops up the rainwater harvesting calculator. The rainwater harvesting calculator is based on the British Standard 8515, and is, in this perspective, just looking at using rainwater harvesting for stormwater control. So we're looking to see what we could potentially use, what storage may be available to utilize to retain stormwater, rather than actually sizing it for everyday use. To do this, there's two different fields we have to fill in. The first one is our annual demand. So we have daily requirement per person, 50 litres, and number of persons. If we assume in our block of flats we had 10 people, we could specify that in there. The second area is our annual yield. So this is how much water we could harvest from the roof area. So our collection area is 500 metres squared, yield coefficient 0.75, and then we just need a SAR value, so standard average annual rainfall. So again, pick Swindon, and we get 706. So now we get a feasibility results. So you can see our demand and our yield. So you can see in this case the demand for water, the demand for the rainwater harvesting is actually less than the amount of water that the roof would supply. Although this may make it very feasible to actually use rainwater harvesting to be able to disconnect from the mains, it doesn't make it feasible to use it for stormwater control. If we had 15 people in our block of flats, you can see the reverse happens. So the writing below as a warning goes to green to basically say that the demand is greater than the supply. Because the demand exceeds the supply, it's possible that the tank won't always be completely full, and so it's able to be used for stormwater control. In this scenario, we can move over to the volume tab. In here, we've got rainfall at the top. So again, we've picked the location where we're working, and it uses various calculations based on the British Standard to calculate what size tank would be required, and so that's coming in just under 30 meters cubed. That then has a spare storage coefficient applied to it. So in this case, coming out of the recommendations from the standards, we apply a 0.5%, so 0.5. So basically 50% of the storage is available for rainwater. The rest we assume is still filled or still full from the previous storm events. So what we actually end up with is just under 15 meters cubed of storage available in the tank. If you're looking to do a more complicated system, or if we go back to it, if you find that your demand isn't as great as your supply, the standards recommend that you run continuous analysis and do a more complicated sort of analysis to work out whether you could use stormwater or could store some stormwater in your rainwater harvesting tanks. But in this scenario, where it goes green, we know we're good to use it. So if we go OK on our time area diagram form, it then automatically updates our summary of results. And we can see what was flooding, 3.4 meters cubed, has now disappeared. This max depth before was well up above 1.5 meters, and you can see it's actually made quite a substantial difference to the size of our storage, the depth of water in our storage structure. And it's possible if we had even a slightly larger tank, again, for rainwater harvesting, we wouldn't need a storage structure here at all. Okay. What I do now is we move back to our main design, and I hand you over to my colleague Peter Coombs, who will take you through the new analysis features and export features we have in version 2013.
Thank you, James, and good afternoon, everybody. What I'll do now is in this session, I'll use James's design to now show how we can audit this particular service water system, and also show you the BIM functions that we now have built into WinDes 2013. So if I go to the wizards drop-down at the top of the screen, you can see that there's an extra wizard here. We now have 9 different wizards that you can run, and I'm going to use the Discharge wizard. So if I click on the Discharge wizard option, notice in the top window I'm focusing on the surface water set scheme that James has just earlier designed. I'll run the summer and winter profile storms and click on next. There are 5 steps to run through. I plan to run through all the different storm durations. So this ranges from 15 minutes up to 10,080 minutes. That's 7 days. Click on the next button. And here we have the return periods. We could put in as many return periods as you wish, but typically nowadays we're focusing on the 1-year return period, the 30-year return period for no flooding, 100-year return period plus climate change to create exceedance and to test our system beyond the design and to better manage the surface water. Click on next. In Scotland, by the way, you'll be using the 200-year return period there with 10% for climate change. And now we can input the discharge rates, the greenfield discharge rates that we would have calculated in the source control module that James just showed you earlier on. So the greenfield discharge rates for the 1-year return period is 32 litres per second, 72 for the 30-year, and 132 for the 100-year. Be aware that we're adding in 30% for climate change on the post-development analysis. So it's quite a robust test. Clicking on the next button, we can then check the greenfield discharge volumetric runoff by clicking on the calculator button. So this is the outfall pipe from the site, pipe 1.018. We can click on the calculate, and in this particular case, the overall gross area of the site is 12 hectares. When I click onto the next cell, you'll notice that the SAR value is being prompted for. James clicked on that earlier on, and we had 700 millimeters a year. There's a straight line correlation between the SAR and the catchment wetness index, so that's automatically populated for you. I need to check the post-development discharge rates and volume against greenfield, so I don't want to put anything in there for urbanization. That would increase the runoff in the greenfield state. And what is the standard percentage runoff? What's the soil type typically for this development? I'm going to put in 25, so reasonably low. Hit calculate, and this is where the figure comes from to test the volume against the greenfield runoff volume. It's 1,799 cubic meters. If I say OK to that, that's now populated in the discharge volume details screen. Now also notice, for the same discharge pipe, I could ask the program to test for the brownfield runoff. So typically a lot of the sites are infill sites nowadays, and maybe a half of the site would be impermeable already. If you were allowed to have the brownfield volumetric discharge, what would it be? Well, if I click on the calculate button, again there's a prompt here to add in the area. Well, let's say that half of the 12 hectares, 6, is actually impermeable, and hit the calculate button. Now we have 3,150 cubic meters of runoff volume from the brownfield. If you're working at a very early stage and you're not sure if you're going to gain that brownfield consent or greenfield, you can run both, and that's what I intend to show you here now. There's also a third option, and that is to have a user-specified methodology. Now, this could be a hand calculation, it could be based on local knowledge, and in this case, the local authority are saying, we've got a really bad problem with flooding downstream, we want to restrict and hold back the volume even less than the greenfield rate, and we want to limit you to 1,500 cubic meters of volumetric runoff. So this has been typed in by hand, hence you see the text in red here. Now, for the 100-year 6-hour event, and we're using the winter profile because that will generate more runoff, it's a more onerous kind of a test. You could add in for climate change if you're looking at code for sustainable homes in the climate change window. I'll leave as is, and then I will also run the minimal discharge test. So the program now is going to apply the first 5 millimeters of rainfall depth onto the network and see what the discharge is, if any, coming at the downstream end. So let's see how James's design is performing. If I click on next and finish, I'll say OK to the warning. We've got a fairly steep pipe at the downstream end of the catchment, and now this wizard will run live and typically take, for this type of site, 10, 12 hectares, about 2 minutes to run. We've got 70 odd properties, 70 odd different pipes in there. that we're testing for. One other point to mention whilst that's running is that if you'd like some motivational training, this is a happy band that I met over in the Middle East about 18 months ago. They were quite happy, actually. Just don't do smiling in photographs over there. But if you're looking at understanding the hydrology behind what I've just explained in terms of calculating discharge rates and the discharge volume, that course G is being run in February, 7th of February, so feel free to go to the website and book or drop a line to Marta on training@microdrainage.co.uk. With regard to the auditing and the discharge volume, then that auditing course, if you don't want to get into too much detail but just do a test, then we're running that on the 14th of March. Okay, I'll go back to the program now and let's have a look at the final results. Okay, I'll just wait for the screen to refresh for you, and there we are. So the summary results from the Discharge Wizard are now being displayed, and we've got 3 different things that we've checked for here. The Greenfield discharge rates, the Greenfield discharge volume, and the minimal discharge check, that first 5 millimeters of runoff, the first flush, that highly polluted runoff. So looking at the tabs on the left-hand side, already we can see there's a difference in color between the different texts. So green meaning that we've passed. So if I click on the discharge rate tab, you can see that the pre-development rates are higher than the post-development rates. So great job there, James. Well done. Managed to hit all 3 with the 130 and 100 year. How about the discharge volumes, pre and post development? Well, we're now generating 1,186 cubic meters of volume post development. So again, really good job on that, based on applying source control structures, porous paving, basins, infiltration basins, etc., etc. Looking at the minimal discharge, we have the one failure here, and that is the fact that we are discharging a rate of 21 liters per second from that outfall pipe, and we need to gain credits with the Code for Sustainable Homes, for example, would have to have 0 discharge. So no prizes here, folks, but if you wanted to post as a question an answer as to how you can actually manage to have a max outflow of 0, that would be most welcome, because we can share that with everybody. Okay, I'll say okay to that. Here are all the results, so you could click on the critical by return period, and then based on the return period in the storm selector window on the top right hand side here, we could then analyze and look at each of those maximum discharge rates. And in the 1 year return period it was 31.1. So nice job. We just would not get the credits, but we would have passed the mandatory Code for Sustainable Home requirements and pretty well all the other requirements that we're being asked to meet in terms of interim code of practice for SUDs, and even the draft Code for Sustainable Homes that's coming through. The other feature I'd like to just show you now, there was a really popular request, is how can we show on the hard copy headings, the printouts, who's designed and who's checked the job. We could always put in the designer, but we could not show who checked. So we've added in the hard copy headings through the site drop-down menu, and the opportunity to list the revision date, who the designer is, what their job title is, who the checker is, and what their title is. And when I say OK, I'll now just take a look at the printout for this Discharge Wizard and show you that the checking box is now in place. So on the File drop-down, I go down to the Print option towards the bottom, click on the Results tab, and I'll just scroll down a little bit until we get to the Discharge Wizard results, tick the box, and then say Update Preview. I'll maximize the screen as well and zoom in so you can see that a little clearer on your screens. So here we are. We've got the designer, the checker, all listed in the hard copy heading, and this is the information that you'd now need to pass on to your code assessors in terms of the discharge rates and the discharge volumes, and you just would not get the credits, as I mentioned, for the the extra work that you've put in there in terms of minimal discharge. Fine. The next step and final step I'd like to show you is to extract all of this information that James has produced in the 3D format. So how do you now extract that back into Civil 3D or back into AutoCAD, full AutoCAD? What we do is, looking at the plan view, is basically what you see is what you get. So from the view options, I can switch off unnecessary layers of information, and I really just want to focus in on the pipe network and then bring that in as a 3D entity across into AutoCAD. So clicking on the view options drop down, I'll come down and switch off things like the drawing image. So I'll turn off the DXF, and there we are. We're now back to just what we're showing in the window, the stormwater sustainable drainage system. And what I can do at the top toolbar here is click on the Save DXF, and I can save out in a DXF or DWG. So just a drawing format, and what I would do is just type in a file name here, so you could go for BIM, stormwater, or whatever, and save that out. Now, I'm just going to replace that file, and we have a DXF export option window that will pop up. What do I wish to save? Do I want to save all the information, or just that which is visible on the screen here? And that's what I want to do. Do I wish to export the pipes and the manholes as 2D or 3D entities? So if I export it as 2D entities, they would just be lines and circles on the drawing. With 3D entities, we're bringing them out as cylinders and boxes if you happen to have rectangular or square manholes, but the round chamber rings and the round pipes would be cylinders. So I'll say OK to that, and that's now been saved out. I can now go into AutoCAD or Civil 3D and then read in that particular file. So let's go to AutoCAD Civil 3D in this instance, and now I'm going to load in my network. So if I click on DXF, because it was saved out as DXF, and I can bring in the stormwater network and open it from there. That has now been brought in. I like working in this format because you literally are just bringing in that information, that drainage information, albeit I've left the pipe labels on there. I could have just brought in the pipes and the manholes, but of course you can now XREF with your drawings, so that saves quite a bit of memory as well. So if I go to the view option here now, and if I go to the orbit, I can now just tilt that up. So Daniel, good day, mate. There you go. That's what it would look like from where you've come from. So you just tilt the 3D view in there, and let's just zoom in. So now we have them all brought in as 3D entities. So just to summarize, what James has shown you is the new module selector, replacing the old dearly loved satellite balls, and I'll be really interested to hear your feedback on that, but very much quicker and easier, and you can see the network here and how these modules really operate with one another. The load speeds for larger files across the local area networks that you're working on, you'll find an improvement with. The BIM, which is becoming very strong on the agenda across all of Europe, Middle East, and Africa that we're dealing with. And also the new DrawNet, which supersedes MD-CAD. So now you have DrawNet CAD, which would either work in WinDes or work in Civil 3D or AutoCAD from the latest versions, 2013. We have the rainwater harvesting function in there as well, based on the British Standard 8515, as well as the very much more simplified and quicker discharge wizard to enable you to check in accordance with the latest standards. Overall, we've added in over 80 additional improvements, and that has actually satisfied 60% of your future requests. So really appreciate those requests coming in, and I hope you really appreciate WinDes 2013. Thank you all very much for listening. I hope you enjoyed the What's New in WinDes 2013. If you have any queries at all about the modules that James or I have been talking about, and you need any help to understand what would enable you to become more productive, then drop us an email on sales@microdrainage.co.uk. If you need any kind of technical support, you're installing the software, or need any help with what you're doing, then support@microdrainage.co.uk. And if you need any help with the training, then drop us a line on training@microdrainage.co.uk. Bye to you all.